which AP tests today. Everybody's here. Let's close this.
I got zeros for 117 and 118, and I think I turned 118 in class before the quiz, and then I turned 117 in after class online.
118 then. If you gave me the hard copy, check that box up there. It may just not have saved it. It would be the top one, and it should be one of the first few papers. You found that one?
Yeah.
Okay. Yeah, probably the internet must have gone down for a second when I was grading them, would be
It's
my
fine.
guess. But
No worries.
I will get to it today. Ryan's senior. Reed is about 3. Marcus made it. Reed made it. Senior, Janie. Alright, good morning guys. We're going to have our bells turned off again today, all this week and all next week for AP testing. So, we are going to look at a big portion of the rest of the stuff. Actually, we'll actually look at all the rest of the stuff on your last unit test, and I guess the last new stuff on the for the final exam as well. We won't finish all the practice today, but we will at least introduce it. So I'd like to spend just a second looking over 121 because this stuff is going to carry over. This was the short little handout, and we're going to copy this information over to today's handout as well. But we talked about on a rational function, how do you go about finding the difference between a hole, an x-intercept, and a vertical asymptote. So knowing what those things look like, knowing their three definitions, make sure that you understand that it can only be one of these at a time. Visually, it doesn't make sense for them to be more than one at a time. And then basically the work was all the same for these. You had to find what numbers made the numerator 0, what numbers made the denominator 0, and if it made both 0, that gave us a hole. If it made just the numerator 0, it was an x-intercept, and if it made just the denominator 0, it was a vertical asymptote. So we're still going to be using that, and the only reason I had you look at this last class is so that hopefully you feel a little comfortable with these, and because we need to add on to that. But on today's handout, this is what we're going to start off with, those three things and the first two questions. So on the front here, I've got a great big box, and what I'd like you to do with this is to put all the notes and summary for how to find each of these things in the box. And then you just have one place that you need to go back and refer to as we work through these questions. Okay, so let's go ahead and put down the notes for the three we talked about last time. So we talked about how to find x-intercepts. X-intercepts always have a y value of 0. This is how the answer should be written. It's a point. And to find it, you need to find x values. And feel free to reword this in any way that makes more sense to you. But x-intercepts are going to come from x values that make only the numerator equal to 0. Now, I'm going to box that off just because to me that's all I would need for x-intercept. But you might want to wait and see if you want to put an example with it later. And of course, the key word there is only, because if it also made the denominator 0, it's no longer an x-intercept, it's a hole instead. Okay, we talked about finding vertical asymptotes. Not every rational function is going to have a vertical asymptote, but those are vertical lines, so the answers will be x equals a number, like all vertical lines. And these came from x values that make only the denominator equal to 0. Again, only is important because if it makes both, it's not a vertical asymptote, it's a hole instead. Again, I know you have these definitions on the other page. I just want this one big box to be one location for all of the things. Okay, and then definitely the hardest, although the first half shouldn't be the hardest, holes are points. So your answer should be listed as a point. Bless you. They're going to be found by finding x values that make both, I'll capitalize the word both, the numerator and denominator equal to 0. Now, the part that I would probably emphasize if I was you, just based on past experience and what students forget about on the test, is the y value of the hole. So we need to write something about that. The y value comes from plugging in the x value of the hole into the reduced fraction. So when there's a number that makes the numerator and denominator 0, we know there's a hole. The x value that's making that happen is the x value of the hole. And to find the y value of the hole, we have to plug in the x value of the hole into a reduced fraction. So we need to cancel out the common factors from the numerator and denominator to reduce it, and then plug in the x value. Okay, those are the three things we talked about last time. So again, hopefully you feel okay with those already. But before I add to that, let's go ahead and start to look at what some of these questions look like. So every one of these questions basically asks the same thing, but you have to do a lot of practice because some questions have holes, some questions don't have holes, some questions have vertical asymptotes, some questions don't have vertical asymptotes. And you have to practice a handful of them so that you get exposure to a little bit of everything. Okay, but if I just answer these three parts first, the parts that we have notes for up above, that would be these three. And we need to think about what numbers make the numerator and denominator 0. Well, the numerator never equals 0. 1 is never equal to 0. There's no x's in there. So that already tells me there's not a number that makes both the numerator and denominator 0. So this question doesn't have a hole. Janine?
Did I leave a book in here?
If you did, it would be back there. I didn't see it, but you're welcome to look for it. X-intercepts are going to occur for any number that makes just the numerator 0, and if there's nothing that makes the numerator 0, then there's not going to be any x-intercepts. But vertical asymptotes are going to occur from numbers that make just the denominator 0. So we should factor it. He's got a GCF. And he factors more. Obviously be careful with the factoring. It doesn't do you any good to factor it wrong. So, and then think about where these equal 0. 3 never equals 0, but -3 equals 0 at -3, or x plus 3 equals 0 at -3, and x minus 2 equals 0 at 2. So there's two numbers that make just a denominator 0, so those will show up as vertical asymptotes. Now, once we have talked about the rules for all of these and combine all of this and do a couple points, we will know what the graph looks like. So obviously not knowing that there's no x-intercepts doesn't help you a ton with your graph, other than to know to make sure it doesn't cross the x-axis. Likewise, not having any holes is not real helpful, but vertical asymptotes we can and should graph. So vertical lines, do these in blue, are all asymptotes, whether they're vertical asymptotes, horizontal asymptotes, or slant asymptotes. You should always graph as a dashed line. So x equals 2 and x equals -3. Those are actually going to go a long way to us figuring out what this graph looks like, because the graph or the function is going to behave a certain way around those asymptotes. But we'll come back to that and worry about that later. Okay, let's do question 2 for just these three parts, and then we'll backtrack and add something to it. Actually, we'll keep, never mind. We'll just do question 2 and then we'll add to it. The problem is, like I said, not every question has a hole. So I see question 1 didn't have a hole. I can already tell question 2 doesn't have a hole. So you're not really getting to practice that yet. But okay, so if we just try the 3 that we have a little bit of exposure to, again, these 3 kind of go together just because you have to figure out what numbers make the numerator and denominator 0. Usually that means you have to factor the numerator and factor the denominator, but not always. Sometimes it's going to be easier than that. I can quickly see numerator equals 0 at 2 only, and denominator equals 0 at 4 only. So there's no number that makes the numerator and denominator 0, which is how you get a hole. There's one number that makes just the numerator 0, which is how you get x-intercepts. And there's one number that makes just a denominator 0, which is how you get vertical asymptotes. X-intercept should be written as a point. If there was a hole, we should write it as a point, but vertical asymptote is a vertical line. It should be written as an equation of a vertical line, x equals. So when we come back to this question, we've got some good information here. We know there's going to be this vertical spike at x equals 4, this asymptote, and we know that this goes through the point 2, 0. So we've got 1 point. In fact, if we insisted you make a certain number of points on the test, you could use that as one of your points. 2, 0 is guaranteed to be on our graph. Okay, so let's go back and let's add to these now. So the next easiest, in my opinion, is going to be y-intercept. Y-intercepts always have an x value of 0. So your answer should be written as a point. And to me, that's all I would probably add for this one. Again, feel free to expand upon that. But y-intercepts have an x value of 0, so I'm just going to plug in 0 for x and solve for y. So, doing this for question 1, I would get 1 over 0 plus 0 minus 18. So when x is 0, y is negative 1/18. That gives us a point for our graph, basically at 0, just a tiny bit under. And then over here on question 2, all y-intercepts have an x value of 0, plug in 0 and solve. You get negative 2 over negative 4, which reduces to 1/2. So there's another point. So that one's consistent with other ways you found y-intercepts in the past. I don't feel like that's one that students usually struggle with. You should feel pretty good about that one. Okay, I'm actually going to come back and do domain at the end once we know what these graphs look like. So next up would be horizontal asymptotes. Most of these are going to have a horizontal asymptote, although not every one. And we actually reviewed these rules earlier this year because we needed to know these for limit questions. So these rules should sound familiar to you. But to find horizontal asymptotes, you need to compare the degrees of the numerator and denominator. If the degree of the numerator is bigger than the degree of the denominator, one thing's going to happen. Or the degree of the denominator could be bigger than the degree of the numerator for a second thing, or the degrees of each could be equal. That's why there's 3 rules, because there's 3 possibilities. The numerator degree could be bigger, the denominator degree could be bigger, or the degrees could be equal. Okay, so when the degree of the numerator is bigger, this is when it does not have a horizontal asymptote. The far right and far left of the graph are going to go up to infinity or down to negative infinity, just depending on the shape of the graph. If the degree of the denominator is bigger, the horizontal asymptote will be y equals 0. And when the degrees were equal, the horizontal asymptote was y equals leading coefficient of numerator divided by leading coefficient of denominator. Of course, you have to remember that leading coefficient means the number multiplied by x with the biggest exponent. Again, these 3 should sound familiar to you because we have used these once or twice this year already. And this is a way to describe the ends of the graph. So this is going to give me good information for my graph as well. So again, you can see you have to practice at least 3 of these questions to even practice one of each of these. But let's do questions 1 and 2 while we have just reviewed these rules. So question 1, the degree of the numerator is 0 because there's no x's. The degree of the denominator is 2. If it helps you, you can do x to the 0 if you need to see its degree. But when the degree of the denominator is bigger, it has a horizontal asymptote of y equals 0. That's an asymptote, so we should graph it as a dashed line. y equals 0 is right on top of the x-axis. So just try to bold it a little bit so you can see it. Okay, question 2. The degree of the numerator is 1. The degree of the denominator is 1. So when the degrees are equal, your horizontal asymptote is going to be y equals leading coefficient over leading coefficient. So 1 over 1, which is of course 1. So y equals 1 is the horizontal asymptote for the second graph. Graph it as a dashed line too. Horizontal asymptotes are obviously horizontal lines, so their equation should be y equals, not x equals. Okay, and then sometimes we have a slant asymptote. Most of the time we don't. I will admit slant asymptote is probably the biggest pain as far as the amount of work. But you certainly don't want to try to find a slant asymptote on every one of these. But we will go past questions 1 and 2, because questions 1 and 2 don't even have slant asymptotes, but we'll keep going until we practice at least one of these. So a slant asymptote is where you have an asymptote like at a diagonal. It's not straight up and down, because that would be vertical asymptote. It's not straight left or right, that's horizontal. It's somewhere in between. Also, just for trivia knowledge here, most of the world call these oblique asymptotes. In America, we tend to call them slant asymptotes more, but if you ever do like a math contest or something, they probably call them oblique asymptotes, but it's the same thing. So, since this is a pain, the first thing you need to learn is when there's even going to be one, because you don't want to do this every single time and it be for nothing. So, it's only going to have a slant asymptote when the degree of the numerator is 1 bigger than the degree of the denominator. So anytime the degree of the numerator is not exactly 1 bigger than the degree of the denominator, we can just say it doesn't have a slant asymptote and move on, which is what's going to be the case most of the time. But when we do have a slant asymptote, unfortunately, the way to find it is it will be y equals, and the way that you get the answer or the equation is it's going to be the quotient and we get to ignore the remainder from long division. We'll have to do long division, and whatever the quotient is, y equals the quotient is the equation of the slant asymptote, or oblique asymptote, same thing. If there's a remainder, we can ignore it. It has no impact on the slant asymptote. Okay, so let's go ahead and start with question 1, and we'll just go through these until we find one that has one, and we'll practice this to make sure that you have that down correctly. Okay, so question 1, the degree of the numerator is 0, degree of the denominator is 2, the degree of the numerator is not 1 bigger than the degree of the denominator, so there is no slant asymptote. Obviously, you should not leave this blank. Say that it doesn't have one. If you leave it blank, it looks like you skipped the question, you didn't know it. Same on a quiz, obviously, too. Question 2, the degree of the numerator is not 1 bigger than the degree of the denominator, so it's not going to have a slant asymptote. Okay, let's keep going until we find one so we can at least practice one. Okay, question 3, degree of the numerator is 3, degree of the denominator is 2, so the degree of the numerator is 1 bigger than the degree of the denominator. So that's all I have to do to know there's a slant asymptote, but to find the equation y equals, we're going to have to do long division. Again, I told you when we did practice long division and synthetic division the other day that we'd be doing this, using that for most of the rest of the stuff we're doing this year. So we're going to try to divide negative 3x squared minus 3x plus 18 into x cubed minus x squared minus 6x. Now, this is not, probably not going to divide into it evenly. I'm not anticipating a remainder of 0. But slant asymptotes, whatever, and honestly I don't really know the mathematics behind it. I probably should look it up, but the remainder just won't have any impact on it. Now also, to be fair, this one's going to have some fractions in it, and fractions, you usually don't have fractions in these. But okay, so I need to think about what times negative 3x squared gives me positive 1x cubed. So I would say do this in steps. Do x's first. X times x squared gives you x cubed. I would say you need to think about positive or negative times a negative to get a positive. So this needs to be negative. Negative times negative gives you positive. And then you have to ask yourself, what times 3 gives me 1? And that would be 1/3. Because multiplying by 1/3 is the same as dividing by 3. So this times this gives me positive 1x cubed. That's why I put that there. I also need to multiply through these two though. Negative times negative is positive. 1/3 times 3 would be 1. X times x is x squared. Try to do it in multiple steps like that. It's too much to do all at once. And then multiply it to 18. Negative times a positive is negative. 18 times 1/3 is like 18 divided by 3. And then x times no more x's would just be x. Switch the signs and add before you forget. Of course, these two should add to 0, otherwise you pick the wrong thing here or you have a mistake. And then combine like terms. Negative 1x squared minus another x squared would be negative 2x squareds. Negative 6x's plus 6x's, these add to 0, so I don't need to keep up with that anymore. And then looks like we can do the algorithm one more time, because there is something times negative 3x squared to get negative 2x squared. So again, do it in like 3 steps. I could think about how many x's times x squared gives me x squared. Well, I don't need any more x's. I've got what I want. Think about positive or negative times a negative to get a negative. So this has to be positive. Positive times negative gives you negative. And then ask yourself, what times 3 gives you 2? Well, if you multiply by 1/3, you would get 1. Multiplying by 1/3 is like dividing by 3. So if I want to double that to make it be 2, we're going to multiply by 2/3. Again, most of the time you don't even really have to do fractions, but okay, so now I'm going to multiply this by this, which is going to give me this part, of course. Multiply it by this. Positive times a negative is negative. 2/3 times 3 would be 2 times x, and 2/3 times 18. So that's like 18 divided by 3, which would be 6, but times 2, which is 12. Change the signs and add. And it looks like we end up with a remainder of 2x minus 12, which is important for most mathematics, not important for slant asymptotes though. It's just the quotient. Y equals the quotient is going to be the equation of our slant asymptote. It's going to be negative 1/3 x plus 2/3. And we can certainly put that on the graph because this is mx plus b. So he's got a y-intercept at 2/3. He's got a slope of negative 1/3. Count down 1, right 3. And a slant asymptote is an asymptote. So graph it as a dashed line. Again, that's going to go a long way to help us figuring out what these graphs look like. Okay, so now we can basically go back to the first page, and we have talked about a little bit of everything except the graphing stuff and domain, but domain's a lot easier to know what once you have the graph. So for question 1, I've already been putting this stuff down as I found it. Dashed lines for asymptotes. We actually got a point out of the x-intercept. I can't graph a slant asymptote if it doesn't have one. I can't graph a hole if it doesn't have one. So this is where I stand right now. So unfortunately, this is probably not quite enough information. I probably need at least another point or two, and then things are going to kind of fall into place pretty quickly. So obviously don't try to plug in 10 for x. That wouldn't help you. That would be off the graph. Don't try to plug in a half. That's going to be harder than necessary. Plug in something easy like maybe 1. Plug it into the original equation. You would get 1 over 3 plus 3 minus 18. So that would be negative 1/12. So still almost 0, but it has come down a little bit from where 0 was. Negative 1/12 is bigger than negative 1/18. Or I'm sorry, it's further down. Negative 1/18 is a bigger number, but 1/12 is bigger than 1/18. Okay, and then I think we could probably get away with just one more. Again, there's nothing wrong with finding a bunch of points. Honestly, if anything, that's going to add to your confidence here. But let's try plugging in negative 1. 3 times negative 1 squared would be 3. 3 times negative 1 would be negative 3. So it looks like plugging in negative 1 gives us negative 1/18. Okay, I lied. So I think we need maybe one more point. Let's try negative 2. Sometimes you don't even need any more points. You'll see that it just kind of depends on the graph. If I plug in negative 2, this one's going to be a little bit harder, but this would be 3 times 4, which would be 12, plus 3 times negative 2, which would be negative 6, and then minus 18. So 1 over 6 minus 18 is negative 1/12. So maybe not the easiest thing to do without a calculator, but it's also not terrible. Okay, now I'm going to show you what the graph looks like and how you're supposed to know what the rest of the graph looks like. And once we know what the graph looks like, domain's going to be pretty easy to come back and fill in. Okay, so if I kind of zoom in here, again, some of these points, all of 4 of these points I found are super close to 0, but some of them are a little further away than others. So I know these points are all connected. I can go ahead and connect them. And of course, if you did more points, that's going to just give you more points to connect. But the last key to the graphing of these, which of course is the end goal, because you've got to be able to do all the rest of this stuff first before the graphs are going to come together. But you need to know how these behave around asymptotes. So around vertical asymptotes, I can't plug in x equals 2 here because this gives me a division by 0. But as I plug in a number almost 2 and a little bit over 2, that fraction is going to be extremely big because the denominator is going to 0, and then in fraction, if your denominator is heading to 0, it's making your fraction bigger and bigger. So the shape of this matters. That's why I kept plugging in points, even though you probably didn't know why. So I can see that this is heading down, and this vertical asymptote, it can't cross it. So it's either got to shoot down to negative infinity or up to positive infinity. I can see that this graph's heading down, so that's how I know it's going to do that. And if it heads down on one side of a vertical asymptote, it's going to head up on the other side of the vertical asymptote. And then same thing over here. Vertical asymptote, so this is going to be the spike in the graph. Based on the direction of this graph, it looks like it spikes down on the right, which means it's going to spike up on the left. And then finally, the last thing we need to know is that horizontal asymptotes and slant asymptotes, you can't have a graph that has both of those, but those are important because they tell you what happens at the ends of the graph. So y equals 0 is the number it's going to approach on the far left and far right of the graph. And then that is what that rational function looks like. Now, of course, I'm going to have you guys practice some of these on your own today, but the best way to check these is by just plugging them in the calculator and a 5-second eyeball test. If your graph in your calculator looks like this, then you can pretty much assume that's correct. I don't have classroom calculators right now, though. They had to take those for some of the AP testing, so you might need to get out your Chromebook and check it by going to like Desmos calculator or something, but you don't need to do that right now. Okay, let's do the same thing with question 2. Oh no, I'm sorry. Let's do the domain. Let's just go ahead and finish it up. So domain, I feel like we've done this enough this year. You probably don't need to write this up in the notes in the top box, but of course feel free to. This is a way to describe the x values of the graph. Basically, it's a math way to say what x values make sense to plug in. Like if you're talking about a real world example with time, typically time starts at 0. We don't say time goes backwards when we look at math questions. So domain with time is usually 0 to something. But for us, it's x values. But now that we have the graph done, we can think about what x values are being hit versus which x values are not being hit. So we're hitting all of these x values, which start at -infinity and keep going up to -3, but it doesn't actually hit -3. Then we hit all of these x values. So I'm going to say and -3 up to 2. Now notice it doesn't reach -3, it doesn't reach 2. That's why I'm using parentheses. And you don't have to use this union symbol, it's just a math way to say and. And we've got this little group, which starts at 2 and goes forever to the right to infinity. So when I go over these, I'll try to color coordinate these for you. All of these x values in red start at the far left and go to -3. All of these x values in purple start at -3 and continue to 2. And then all of these x values that start at 2 and go forever to the right. So realistically, what you're really doing is you're taking out any vertical asymptote from the domain. I'm basically saying skip -3, skip +2. And if there had been a hole in the graph, we would have to skip that x value because that x value wouldn't exist. But this one didn't have a hole. Okay, so now it's really just, we need some repetition and practice graphing these so that all of this gets easier and comes together. Again, I said none of these individually are that difficult. It's just a lot of information if you don't remember any of it from last year. Okay, so in this question, again, you could do more points on the test. We'll probably insist you do 5 or 6 points, and part of that is just going to be trying to convince you to check and make sure whatever points you plug in are consistent with the graph. But truthfully, in question 2, I am ready to graph this already because I've got 2 points, so I know they're going to be connected. I know how it behaves around a vertical asymptote. It's going to spike down on one side and spike up on the other side. Based on the direction of this, I can tell it's spiking down on the left, so spiking up on the right. And then horizontal asymptote tells me what it's going to approach the further left you go and the further right you go. So I really didn't even have to find more points for that graph. I had enough. It just depends on the information you have, whether you need to find more points. But of course on the test, if you had extra time, it wouldn't be a terrible idea to go ahead and plug in 5 maybe into the function, because if you plug 5 into the function and you get something negative, and then at x equals 5 you're not down here in the negatives, you would at least know something's wrong. You didn't do something right and you would know to stick with it. So, but if you plugged in 5 and you got 2 or something, that makes sense. Alright, so now for the domain, it looks like it's hitting all of these values, everything from the far left up to x equals 4. And then it starts hitting all of these x values, which start at 4 and go forever to the right. So fancy, long-winded mathematical way to say you can plug in anything you want for x except for 4. You can plug in the numbers less than 4 and the numbers bigger than 4. But that's how we like to write it. Okay, so we're going to go over 2 more together, but now I'm going to be going through the rules a little bit quicker. Again, I understand that you don't have all of these rules memorized, and that's where this handout's so thick so that you get a bunch of practice. Okay, but when I ask you to try a question in just a minute, so again, I'm going to go over 3 and 4 for you, complete from scratch. But when I ask you to work question 5 on your own in a few minutes, you really should just start off with whatever you feel most comfortable with. Start off with the easy ones. Hopefully that's y-intercept. Y-intercepts always have an x value of 0. Plug in 0, solve, you get 0. Add it to your graph. 0, 0 is going to be a point on my graph. And then branch out. Maybe you think the next easiest is x-intercepts, vertical asymptotes, and holes, because we talked about that some last class. So you're going to have to think about what numbers make the numerator and denominator 0. So sometimes it requires factoring, sometimes it does not. But both of these have a GCF. Okay, and again, that's just depends question to question. Question 2, we didn't have to do any of this, so that made question 2 a little bit easier. But question 3, GCFs and factoring trinomials to determine that there's 2 numbers that make just the denominator 0. So those end up as vertical asymptotes. Any asymptote should be graphed on our line as a dashed line. And as we saw from the front page, that actually does help us a lot with our graph. Any number that makes just the numerator 0, it's going to be x-intercepts. So 0, -2, and 3. And again, those are points, so please write them as points. Now this one I already kind of knew. Not only is the origin an x-intercept, but it's a y-intercept too. So it's good to see the consistency there. I already had this point, but I could plot -2, 0 and 3, 0. And again, we don't need a million points to be able to graph these, so any points we're getting is good news. Of course, if you were asked to make a table on the test, feel free to use these points that you're finding. Add them to the table. Okay, and then maybe you don't have the horizontal asymptote rules memorized yet. That is fine. So you could look back to the front page, you could look at the box where we wrote all that down again, but then as you work from question to question, you should try to be referring to that less and less and less. So on this one, oh, I'm sorry, we should do holes. There's no number that makes the numerator and denominator 0, so no hole. Okay, horizontal asymptotes, you compare the degrees. If the degree of the numerator is bigger, then it doesn't have a horizontal asymptote. That's about 1 second of work if you really know those rules. Okay, we still need to do the domain, but again, I think the domain's a little bit easier to do once we have the graph in front of us. Okay, so horizontal asymptotes and slant asymptotes, you need to remember those are trying to tell you what's happening at the ends of the graph. So I can tell that this is a point on my graph. It's got to approach the slant asymptote as it gets further to the right. Based on this shape and how it has to interact around a vertical asymptote, it must be spiking up on the right side and spiking down on the left side. which is consistent with these points. It's coming down on this side so that it can hit this point, and then it must turn around and hit this point. And then based on this direction, it must be spiking down on the right side of this vertical asymptote, so the up on the left side. And just like it approaches the slant asymptote on the far right, it also has to approach the slant asymptote on the far left. Horizontal asymptotes and slant asymptotes are telling you what it approaches at the ends. Now, it can actually cross the graph in the middle. That's a common misconception. Since this has 3 sections here, 1, 2, 3, some equations, your graph could cross the slant asymptote in the middle, but at the ends it only approaches. Okay, now that I've got the graph in front of me, I can see the x values that are being hit. These are negative infinity up to -3. These are -3 to 2. And then the last little section is 2 to infinity. And you can see I just put those, tried to color them with the 3 little intervals. Basically, we're just skipping any x value that we couldn't get, which would be vertical asymptotes and holes. Now again, a large part of how I can do that so quickly is I know those rules, and you may not be able to do them that quickly until you get near the end. And we'd already done the slant asymptote, to be fair. That would have taken a couple more minutes. Okay, but from scratch, one more time. So, all the same rules, and I don't mind saying these rules 50 times to you guys, but the rules for finding a hole is not going to change. The rules for finding a vertical asymptote is not going to change. That's why I like you to have all that summarized in that big box on the front page. But when I ask you to do question 5 in just a second, feel free to start off with whatever seems easiest. If you think y-intercepts are easiest, start off with that. If you think horizontal asymptote rules are easy to use, start off with that. If you don't remember how or when there's a slant asymptote, then look back on the front page, use your notes, but then maybe on the next question, try not to look at that. Try to use your notes less and less. The degree of the numerator is not 1 bigger than the degree of the denominator, so no slant. These 3, I have to compare what numbers make the numerator and denominator 0. So, some factoring, some GCF factoring, again, you don't have to rush through that, but there's a couple numbers that make the numerator 0, and a couple numbers that make the denominator 0. And as long as you know the definition, you're on the way to getting 3 of those answers. Numbers that make just the denominator 0, vertical asymptotes, vertical lines. Numbers that make just the numerator 0 are x-intercepts, that's a point. And any numbers that make the numerator and denominator 0, I think this might be the first one we've seen of this today, but we practiced this a lot yesterday, or Monday. Any number that makes both the numerator and the denominator 0 is the x value of the whole. To find the y value of the whole, you need to plug in the x value of the whole into the reduced fraction. So let the x plus 3 cancel out the x plus 3, and then plug it into what's left behind. That would be -3 minus 2 on top, and -4 times -3 plus 1 on bottom. Which is -5/8. Again, that's the one that students, I would say probably the most common mistake on your next test will be that. And the problem is you just don't get to practice at every single question. Not every question has a hole, so not every question do you get to practice finding the y value. But it would probably not be a terrible idea to make sure you emphasize that part of your notes. Okay, so I've got some points here. So if I had to make a table, I guess I could add that. I had x-intercept. And then I can start throwing all this on the graph. I've got 2 points. I've got a vertical asymptote. I've got a horizontal asymptote. If I'm not sure where the graph should be going from here, oh, I also have a hole, by the way. The hole does help you, and you do need to graph the hole on your graph. But of course it needs to be an open circle because it's missing that. At x equals -3, it almost hit y equals -5/8. Bless you. Make sure you show that as an open circle for the hole. If you're not sure if your graph is on the right track or you don't know what it looks like, start plugging in some x values into the function, add to your t-chart, plot those points until you do feel comfortable. Sometimes you have to get more points like question 1. Sometimes you've got plenty to work with. I think this one we have plenty to work with because I know these 2 points have to be connected. Based on the shape of this graph and how it has to interact on a vertical asymptote, it's either got to go up to infinity or down to -infinity. But based on this shape, this one's going up to the right, so down to the left. You might not think the hole's going to help, but it actually does because the hole is going to hit the points right before and right after, just not the points at that instant. So I know this is going to go to this, skip that value, and then keep going. And then it's helpful to have a slant asymptote or a horizontal asymptote because that tells me the y value it approaches at the ends. It's close to -1/4 on the left and close to -1/4 on the right. And then of course the best way to check that is to put the original equation into your calculator, graph it. If the overall shape of the graph looks the same, then it's probably fine. And if it doesn't, it should give you a hint about, wait, why is there a vertical spike at 4? I didn't think there was a vertical asymptote at 4. It should give you some hints on how to move on from that. Okay, and then finally for domain, again, domain is trying to describe the x values that your graph is hitting. So we've got to take out vertical asymptotes and holes. So down here, it hits everything from -infinity until we got to -3. It has no value at -3, so we can't include -3. Then it hits a few more from -3 to -1. Then it hits everything from -1 forever to the right. So that would be the domain. And I'll copy that up here. Okay, so of course I'm going to help you out with some of the other ones, but you honestly, me just saying the rules 100 times doesn't help as much as you guys try and, again, start off with the ones you feel like you know. Try to answer those. When you start to slow down or get stuck, look back at the front page. Try to get the information you need, but also try to learn it so you don't have to keep looking back at it. And then each one of these should get a little bit easier as time goes on. So go ahead and start question 5. And I'm going to assume you guys are going to be a little bit slower here at first, so make sure you're done with at least question 5 in about 10 minutes. And then I will zip through the rules and give you guys a chance to ask specific questions, and I will also share the graph on my screen at the end. But if you have your own calculator, I'd also recommend you graph it. Since I don't have a classroom set of calculators today, if you want to pull that up on Desmos on your Chromebook, that's understandable too. Also, make sure you see that negative in front. If you miss that negative, your graph is probably going to be upside down. Let's give everybody about 2 more minutes before I go over it, but I think most of you should be finished or close to finished. So here's a picture of the graph. Here's looks nothing like that. It should at least give you some hints about maybe what you need to do. Like if you only thought there was one vertical asymptote, you should be able to see 2 there, so something's definitely off. if you did not get close to that, go ahead and follow along with me. But if your graph looks the same as this, that means most of it is right. It doesn't guarantee everything is right, because you could still have messed up the domain, or there could be a hole or not a hole opposite of what you actually think. So again, as I start going through these, I'm going to verbalize the rules every time, but I'm not saying anything different. So at some point you just have to force yourself to memorize those definitions and those rules. One thing I would recommend though, when you've got a negative out sign like this, you might change this to plus a negative. So having that negative next to the 4 makes it a little easier to not forget about. So I'm just going to do these in the order that I showed them to you. The 3 we talked about last time, there's nothing that makes the numerator 0, but there's 2 things that make the denominator 0. There's nothing that makes the numerator and denominator 0, so no holes. There's nothing that makes just the numerator 0. This is not going to cross the x-axis. But there's 2 numbers that make just the denominator 0, which is how you get vertical asymptotes. Now again, I'm very comfortable with those definitions and those rules, which is how I can do it so quickly, but you will get there as well. You should have to think about that less and less as you go along. Okay, then today we started off with y-intercepts, which is where you try to plug in 0 for x and solve, and you would get -4 over 0, which you can't do. -4 over 0 is undefined. So that's how I know this guy is not going to have a y-intercept. Horizontal asymptotes is the rule where I compared the degrees. If the degree of the numerator is bigger, it doesn't have one. Degree of the denominator is bigger, it's y equals 0. And if the degrees were equal, it would be leading coefficient over leading coefficient. Once again, another 5 seconds worth of work if you know the rule. Slant asymptote is the one that's a pain, where we have to do long division. Y equals the quotient, ignore the remainder, but only when the degree of the numerator is 1 bigger than the degree of the denominator, which is not this question. So I don't have to do that this time. Now, unfortunately, I've only got a couple things for my graph this time. I've got 3 asymptotes. X equals 0, x equals 3, and y equals 0. So those are great to have. They help you with the direction of the graph and the shape of the graph, but you've got to have something to start with. So it's just unfortunate that none of that work up there gave you enough points, but we can just find some other points by plugging in some easy numbers. Again, don't plug in 1/2 for x. That's going to not be easy to do without a calculator. Maybe plug in 1. That would be -4 over -2, which reduces to 2. So when x is 1, y is 2. I'm not confident enough yet in my graph, so I'm going to try another point or 2. Maybe plug in 2 to get -4 over 4 minus 6, which would be -2, and 2 again. Okay, and again, y'all can do as many points as you need to. If you are not sure if you have enough points, then you don't have enough points. But I can tell from this, if these are the same, this graph doesn't just go horizontal all of a sudden. What it's doing is it's going down through this, and then it's having to turn right back around to go back up through this. So now I know the shape of the graph. It's spiking up on this side, so it must be spiking down on that side. Spiking up on this side, so it must be spiking down on this side. And horizontal asymptote tells me what it approaches on the far left / far right of the graph. So even with having 0 points, just a point or 2 is often enough. And again, if we just eyeball test our graph to what the calculator or Desmo says, they better look basically the same. If something looks different, then something in your work is off. Those two look the same to me, so I would check it off and go on. Okay, so next up, if you would please try question 6. Oh, no, I'm sorry, we've got to do the domain too. So your domain was everything except these 2 vertical asymptotes. So you should have skipped 0, everything from negative infinity to 0, skip 0, everything from 0 to 3, skip 3, and then everything after 3. So whatever rules you had to look up on the front page for question 5, try to not look up some of those for question 6. But do the same thing with question 6. Start with the ones you're most confident with, work your way up until you get to ones you're less confident with, and then lean on your notes on the front page to help you. So once again, I think 10 minutes is going to be too much time here, but I will give you 10 minutes to try question 6 before I go over it with you. So finish that and then keep going, of course. I will ask you to do this whole thing, so. If you ran out of time or you just didn't check it, looks like this is what we're aiming for on this one. So again, having that picture of the graph doesn't 100% confirm everything, but it does help find some glaring issues. Okay, and if you did not come up with that, let's see what went wrong. So, y-intercept, plug in 0 for x, solve for y, you get 1/4. I can quickly tell that the numerator equals 0 at 4. The denominator, I should factor out a GCF to see that it is equal 0 at -4. So no numbers make the numerator and denominator 0, which is how you get a whole. One number makes just the numerator 0, which is why there's an x-intercept at 4. And one number makes just the denominator 0, which is why there's one vertical asymptote, one vertical spike at x equals 4. Horizontal asymptote, compare the degrees. The degrees are equal, so it will be y equals leading coefficient over leading coefficient. Slant asymptote is long division, y equals the quotient, ignore the remainder, but only when the degree of the numerator is 1 bigger than the degree of the denominator, which is not in this case. We start throwing this stuff on the graph. Got a y-intercept. We've got an x-intercept, we've got a vertical asymptote, we've got a horizontal asymptote. Again, there's nothing wrong with getting more points, especially if you feel unsure about your answer or your work, but I think this is going to be plenty, because it's got to approach this on the far right. Based on this direction, it's slowly heading up, so it must go up to infinity on the right side of the vertical asymptote and negative infinity on the left side of the vertical asymptote, and then it has to approach the horizontal asymptote on the left as well. So looks like the degree, or the domain, should be everything from the left to -4, negative infinity to -4, and then all of this stuff, which is -4 from infinity. So basically, numbers less than -4 and numbers bigger than -4. Just a long way to say everything except for -4. But, okay, and then just a quick snapshot, my graph versus the actual graph. Now, if you wanted to even look closer, our graphs on our paper today are not -10 to 10 and -10 to 10. They're actually -5 to 5 and -5 to 5. So if you want to change the window settings, it will make the graph should make it look even closer to what we've got. So actual graph compared to my graph, it's not going to be 100% perfect because I'm not graphing hundreds, if not thousands of points like the calculator is, but it's pretty good considering how much time we spent on it. Okay, so if you have not yet, please move on to question 7. Same thing, I'll give you 10 minutes, even though I'm hoping it's not taking you that long, but 10 minutes I'll go over 7. And then I'll tell you, I do want you to do a couple more of these, like 2 more of them between now and next Monday. This is a B week, so I don't see you again. But that's mostly just to make you try to think about it again. So you don't have to have this finished. This is not all going to be homework. I just want you to do a couple for homework so that you're slowly picking up on all these definitions and rules and stuff. So we'll time to finish 7, go over 7, and then do at least 8 and 9 for homework, please. since you have two vertical asymptotes, you kind of got three sections for your graph. The left section, the middle section, and the right section. The middle section, you can actually cross through the horizontal asymptote. All the horizontal asymptotes just slowly starts to come apart.
So there's no impact.
There is, but if you cross it in the middle, it just can't cross it at the end. It just can't approach it that fast. But if it's got a middle section, you can actually do it. It's just not common, but it can happen. Okay, let me graph this one for you and then go over it and see if you guys have any questions you might want to ask before you leave for today. All right, so number 7, we are aiming for something that looks like this. And again, the graph is the hardest part. If you're messing up a couple of these or not knowing how to figure out a couple of these, then yeah, you're not going to be close to the graph yet. The graph is where you start to feel like it all kind of comes together. All right, but to come up with that, so y-intercept, plug in 0 for x and solve, you get -2/3. X-intercept, think about what numbers make the numerator and denominator equal to 0. If there's any number that makes both, it's a whole. If there's any number that makes just the numerator, it's an x-intercept. If there's any number that makes just a denominator, it's a vertical asymptote. Even though I usually do domain at the end, again, there's only two types of numbers that get cut out of the domain. If there's a whole, it's skipping an x value. If there's vertical asymptotes, it's skipping an x value. So really I want everything from -infinity to +infinity, but I need it to skip -3. So again, I usually do that once I have the graph, but you can do it algebraically. Horizontal asymptote, the degrees are equal, so y equals leading coefficient over leading coefficient. And slant asymptote is the one that's a pain, but as you're starting to figure out, it doesn't come up very often. The degree of the numerator is not one bigger than the degree of the denominator, so I don't have to worry about slant asymptote this time. We start throwing all this on our graph. We got a couple points. We've got a vertical asymptote. Again, make sure you're graphing the asymptotes as dashed lines. We've got a slant asymptote. Make sure you put some thought into whether -1/2 or -2/3 is farther down. You don't want this point to be on the wrong side of that line, because again, if you mess up one of these things, your graph starts to get real confusing because you're trying to make things fit together that don't really fit together. And then that leaves you with this, and again, will probably require you to get more points. It's not a bad idea to get more points, but honestly this is enough because I know it has to approach the horizontal asymptote on the right and left of the graph. I know it's got a spike on the vertical asymptote. Based on the shape of this, it's going up on the left, down on the right, which is consistent to hit that point. If the blanks up above are correct, then your graph should all fit together. If something's wrong, it's going to feel really awkward and it's going to feel forced. Everything should come together and make sense in the end. Okay, so we've got about 8 minutes here, but again, all I'm asking you to do for homework is please do at least question 8 and 9. I'd like you to think about those things again, make a little bit of progress on those notes, and memorizing those definitions. But again, I think other than maybe 1 or 2 little things that just aren't coming to me, I'm pretty sure that this is the last of the new stuff for this unit. So it'll just be practicing this and going over your 2.5 quiz and testing on this, and then this stuff will be on the semester test as well. But this is one of the last new things you need to do for me and practice and get good at this year. So I guess in theory you could even go home, finish all of this, and you might not have to learn anything new for this class the rest of the year, potentially. So again, there might be 1 or 2 little things, but this is all the big stuff for sure. Okay, if y'all have specific questions while you're here, of course, please ask, because you do have time, still have 7 minutes or so. And it is a B week, so I won't see you again until Monday, so you got plenty of time to do these 2 questions. Please do them before you forget about them.